Welcome again to Astronomy Daily. I'm Steve Dunkley, your human host. It's the 24th of February, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh yes, and thank you for joining us here at Astronomy Daily, come to you from the studio in Paradise. That's right, Newcastle, Australia. Currently 36 degrees. I'm so glad to be indoors. That's Celsius for all of you who are wondering. It's a perfect summer's day here on Australia's beautiful east coast. Not a cloud in the sky. The sun is baking us. Yes, and as Dylan Moran once said, we're all audibly crackling down here. We're only 3 kilometres from the surface of the sun. Didn't you know that? It is hot, hot, hot. And joining me again is my digital reporter pal who's fun to be with. Welcome back, Hallie.
Hi, favorite human. What's new?
Oh, Hallie, just another week in the real world, just enjoying all the news from the Astronomy Daily newsletter. Now, have you found your stories for today?
Yes, I have. You'll like one about the mysterious Space Force spaceplane.
Oh, stop it. Space Force, you know what that means.
Yes, your favorite.
Oh, people, get ready.
The Space Force theme music.
Space Force!
Oh, dear.
I'll just collect myself. And what else have you got for us, Hallie?
Oh.
Yes?
SpaceX has completed a substantial static fire test that I'll also report on.
That sounds very good.
It looks promising.
That's great, Hallie. It's not Space Force, but it's really good. And I am going to have a look at a fast-moving star astronomers have discovered toward the center of the galaxy, and you won't believe just how fast we're talking with this one.
How fast are we talking then?
Well, Hallie, remember that time you asked me to put away the memory cards from the recording sessions last year?
Yes, and I'm still waiting. Anything to get out of a little work.
Yeah, okay. Well, this star is way faster than that, okay?
Okay, that's pretty quick. Let me tell you, listeners.
She said not very convincingly.
That's a fact.
Yeah, okay, enough of that shenanigans. But before we get stuck into today's stories, Hallie, I've got a quick update regarding that approaching asteroid that's been in the news lately.
The one causing all the rumors about certain destruction in 2032.
Yes, that's the one, Hallie, straight off the wire today. Asteroid 2024 YR4, as listeners might be already aware, is a recently discovered near-Earth object currently being closely monitored by NASA's planetary defense teams. Initial observations suggested there might be a potential risk of impact with Earth in the future, but thankfully updated calculations have significantly reduced this possibility. Based on the latest data, the asteroid has an extremely low probability, 0.28% of impacting Earth on December 22, 2032. However, its chances of colliding with the Moon have slightly increased to 1%.
So, I can see that the asteroid's orbit continues to be refined through ongoing observations, with NASA's Jet Propulsion Laboratory Sentry system providing real-time updates on its trajectory.
That is exactly how it works, and while asteroid 2024 YR4 doesn't currently pose a significant threat, scientists are remaining vigilant, tracking its movements to give more accurate predictions and to assess any potential future risks, just in case.
That's very wise. And this is why we shouldn't jump to conclusions about trajectories and potential impacts so soon.
That's right. The asteroid is a near-Earth object of the Apollo type with a estimated diameter between 40 and 90 meters, and it was discovered on December 27, 2024 by ATLAS, which is the Asteroid Terrestrial Impact Last Alert System at its Chilean station in Rio Hurtado.
So nothing to be concerned about after all.
Nothing at all, but who knows, we might get to see a spectacular impact on the Moon, maybe, perhaps.
Maybe. Wouldn't that be something?
And it's good to know that Atlas is watching the skies.
Thanks for that update, human. Now shall we just launch into the episode then?
Good idea, Hallie. Hit the go thing.
Righto. Last week, Ship 34 completed its engine testing campaign with a long-duration static fire. This static fire was nearly a minute long, and according to SpaceX, the extended firing tested new hardware and cycled the 6 Raptor engines through multiple thrust levels to recreate different conditions seen within the propulsion system during flight. Data from the test will inform upgrades to the ship's hardware and flight profile ahead of the next launch. The new hardware that SpaceX tested was likely related to the anomaly that occurred during Flight 7 and resulted in the loss of Ship 33. This could have been a leak in the liquid oxygen and liquid methane supply lines to the engines, which could have been the source of the fire seen during Ship 33's ascent burn. However, there is no official confirmation from SpaceX regarding the actual cause of the failure. This test was also done to inform of other upgrades to the vehicle and possible changes to the flight profile, so it is likely that SpaceX still has modifications to be made on Ship 34. It is unclear what these modifications could be or how long it will take SpaceX to implement them on Ship 34. This long-duration static fire is the longest SpaceX has ever fired a Starship or booster on the ground, and it can do this because of the flame trench at Massey's. It is unclear if this will be a one-time test, or if crews will do longer-duration static fire in the future. There are a few things that SpaceX will likely add to the flight, considering several things couldn't be tested on Flight 7. Firstly, there are the dummy Starlinks which were loaded into Ship 33, a new batch of them was seen in Star Factory to be presumably loaded on Ship 34 just before rollout to the launch site. SpaceX might use the new Starlink loader box that was built inside High Bay, rather than the tray loader used on Ship 33. As for the other items expected to be added to Ship 34, there is the actively cooled tile for testing as well as the catch pins. These catch pins are likely to be just bolted on as SpaceX does not intend to catch Ship 34. Lastly, crews will likely remove all of the tiles that were removed on Ship 33 to help understand the limits of losing a tile in certain places during re-entry. An interesting note about Ship 34's engine testing campaign is it took SpaceX 72 hours to roll it to Massey's, static fire it, and then roll it back to Mega Bay 2. This is a record compared to every other ship in the past. Booster 15 was static fired on February 9th, and it was just the normal 10-second static fire with all 33 engines. With this out of the way, SpaceX rolled the booster back into Mega Bay 1 for final checkouts and has since received its hot stage ring. SpaceX completed the rollout, mount on the orbital launch mount, and rollback of the booster in just over 61 hours, which is a new record for boosters. This booster doesn't have any major outside changes that are noticeable, but it was the first booster to have the added tanks on the landing tank. But, older boosters were likely retrofitted with this upgrade. The final two pieces of the puzzle for Flight 8 are the launch pad and the regulatory side. First, SpaceX has finally found a rhythm with refurbishing Orbital Launch Pad A, which takes about 2 to 3 weeks to refurbish for a booster static fire. Then, we will have another few weeks to get it ready for launch again. The second piece is waiting for the mishap investigation to be completed. So far there is no indication of when this might be completed. However, given the post SpaceX made after the long-duration Ship 34 static fire, the final part of that investigation could be nearing a close. The next thing to watch out for is a SpaceX post detailing the anomaly's cause and the fixes they are implementing. The Federal Aviation Administration will also likely post about approving Starship for return to flight after the completed investigation. If SpaceX follows the same trajectory and splashdown locations, the license that is currently issued for Starship should still be current. Currently there is a notice to airmen for Mexican airspace for February 26, with a window of 6:30 p.m. to 8:09 p.m. Central Standard Time. With all this in mind, SpaceX still has a lot of work to do to launch Flight 8 in less than a week.
Astronomy Daily, the podcast.
If you're going to call aliens, you better use this number. Let's dive into one of those cosmic curiosities that's bound to blow your mind. How about we call some aliens and chat? No, and not talking about elaborate coded messages or flashy signals. We're talking about something incredibly fundamental, 21 centimeter radiation. And if you're planning on having a conversation across the vastness of space using light waves or electromagnetic radiation, it's pretty much your go-to option. It's fast, reliable, and, well, it's the most practical way to shout out to other civilizations in the universe. But why specifically 21 centimeters? Well, that's where things get juicy. This 21 centimeter radiation isn't just some random frequency we picked out of a hat. It's tied to something very essential known as the hydrogen spin flip. Hydrogen atoms consist of one proton and one electron. These tiny particles have a property called spin. Think of spin like a little arrow pointing up or pointing down. Every so often in the vast reaches of space, a hydrogen atom's electron can flip its spin, going from a state where its spin is aligned with the proton to one pointing in the opposite direction. This flip releases energy in the form of radiation at, you guessed it, a wavelength of 21 centimeters. So why does this matter? Well, Any smart civilization, whether they have blue skin tentacles or something more bizarre, will eventually discover hydrogen and understand that spin, dabble in quantum mechanics and figure out this whole 21 centimetre radiation thing, and they might call it something different. They won't have 21 or maybe centimetres, but the concept remains universal. It's like the cosmic Rosetta Stone. And what makes 21 centimetre radiation perfect for long-distance interstellar chats is its ability to cut through interstellar dust. Space is filthy, with dust clouds that block out other forms of light. However, 21 centimetre waves are like the VIPs of the universe, slipping through velvet ropes of cosmic debris to carry their message far and wide. Here's the fun fact. NASA's Pioneer spacecraft, launched in the early 1970s, carry plaques, and on these plaques there's a handy diagram of the hydrogen spin flip transition. All other measurements on the plaque, including the height of humans, are made in reference to this fundamental distance. So the hope is that aliens can recognise the hydrogen spin flip transition and use that to unlock the rest of our message. Now imagine this scenario. One day astronomers on Earth detect an unusual surge of 21 centimetre radiation, and it's not coming from a random hydrogen cloud, it's directional, purposeful, and that could very well be an alien civilization sending us a "what's up" across the cosmos. A 21 centimetre radiation makes for a great calling card. Using 21 centimetre radiation to communicate with extraterrestrial beings leverages a basic universal constant, and who knows, maybe one day when we finally hear that signal, we'll know that somewhere out there other intelligent species figured out the same galactic hack we did. So keep your eyes, or rather your telescopes, peeled. The next big discovery could just be a spin flip away. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
The United States Space Force just offered a rare glimpse of its shadowy X-37B spaceplane in orbit. The photo, released on Thursday, February 20th, was taken by a camera on board the X-37B while the secretive spaceplane orbited high above the African continent. One of the plane's solar panels is visible on the left side of the photo, while what appears to be its open payload bay is visible along the top edge. The vehicle has been in orbit for well over a year now, having launched on its 7th mission on December 28, 2023 atop a SpaceX Falcon Heavy rocket. And now, the X-37B has notched another milestone with the Space Force's release of this photo, the first ever image of this spaceplane in orbit that has been shown to the public. While the photo contains scant details about the vehicle and what it's currently testing, it offers a look at Earth in the background, revealing just how high the vehicle is flying on its 7th mission. We've gotten only one other glimpse at the X-37B in orbit prior to this. During the live stream of its most recent launch, a brief shot of the spacecraft deploying from Falcon Heavy's upper stage was seen while its service module was still attached. When the X-37B was preparing to launch on its current mission, the U.S. Space Force revealed the flight would include operating the reusable spaceplane in new orbital regimes, experimenting with future space domain awareness technologies, and investigating the radiation effects on materials provided by NASA, according to a Space Force statement. Previous X-37B missions were flown in low Earth orbit, but as this photo reveals, the spaceplane is currently operating much farther from Earth. SpaceX's Falcon Heavy is capable of launching payloads into geosynchronous orbit, over 22,000 miles (35,000 kilometers) above our planet. The X-37B recently made headlines when Space Force and Boeing, who built the vehicle, revealed that it would be testing a new aerobraking maneuver that uses the drag, or friction, generated by Earth's atmosphere to change orbit more efficiently.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Did you notice how Hallie managed to get my Space Force story? It's funny how she sneaks away with things like that. Meanwhile, astronomers have found a small, fast-moving star racing through the centre of our galaxy, possibly with a planet in orbit. If confirmed, this would be the fastest known exoplanet system, travelling nearly twice as fast as our solar system through the Milky Way. You may be wondering how fast that actually is. Hey, I once got an Amazon delivery in less than 24 hours, but that's just peanuts to how fast this star seems to be tearing across space. The system is estimated to be moving at an incredible speed, now wait for this, of at least 1.2 million miles per hour. That's 540 kilometers per second. Wow. We think this is a so-called super Neptune world orbiting a low-mass star at a distance that would be lie between the orbits of Venus and Earth if it were in our solar system, said Sean Terry, a postdoctoral researcher at the University of Maryland and NASA's Goddard Space Flight Center in Greenbelt, Maryland. Since the star is so feeble, that's well outside its habitable zone. If so, it will be the first planet ever found orbiting a hypervelocity star. The findings, led by Terry, were published in the Astronomical Journal on February 10. The pair of objects was first spotted indirectly in 2011 thanks to a chance alignment. A team of scientists combs through the archive data of MOA, that's the microlensing observations in astrophysics, a collaborative project focused on microlensing survey conducted in the University of Canterbury Mount John Observatory in New Zealand, in search of light signals that betray the presence of exoplanets or planets outside our solar system. Microlensing occurs when the presence of mass warps the fabric of space-time. Anytime an intervening object appears to drift near a background star, light from the star curves as it travels through the warped space-time around the nearer object. If the alignment is especially close, the warping around the object can act like a natural lens, amplifying the background star's light. In this case, microlensing signals reveal a pair of celestial bodies. Scientists determined their relative masses. One is about 2,300 times heavier than the other, but their exact masses depend on how far away they are from the Earth. It's sort of like how the magnification changes if you hold a magnifying glass over a page and move it up and down. Determining the mass ratio is easy, said David Bennett, a senior research scientist at the University of Maryland, College Park, and NASA Goddard, who co-authored the paper and led the original study in 2011. It's much more difficult, he said, to calculate their actual masses. The 2011 Discovery team suspected the microlensed object were either a star about 20% as massive as our Sun and a planet roughly 29 times heavier than the Earth, or near a rogue planet about 4 times Jupiter's mass with a moon smaller than Earth. To figure out which explanation is more likely, astronomers searched through data from Keck Observatory in Hawaii and the European Space Agency's Gaia satellite. If the pair were a rogue planet and moon, they'd be effectively invisible. Dark objects get lost in the inky void of space, but scientists might be able to identify the star if the alternative explanation were correct, though the orbiting planet would be much too faint to actually see. They found a strong suspect located about 24,000 light-years away, putting it within the Milky Way's galactic bulge, the central hub where the stars are more densely packed. By comparing the star's location in 2011 and 2021, the team calculated its high speed. But that's just its 2D motion. If it's also moving toward or away from us, it must be moving even faster. Its true speed may be high enough to exceed the galaxy's escape velocity of just over 1.3 miles per hour, or about 600 kilometers per second. If so, the planetary system is destined to traverse the intergalactic space many millions of years into the future. To To be certain the new identified star is part of the system that caused the 2011 signal, we'd like to look again in another year and see if it moves the right amount and in the right direction to confirm it came from the point where we detected the signal, Bennett said. If a high-resolution observation shows that the star just stays in the same position, then we can tell for sure that it's not part of the system that caused that signal, said Aparna Bhattacharya, a research scientist at University of Maryland College Park and NASA Goddard, who co-authored the new paper. That would mean the rogue planet and exomoon model is favoured. NASA's upcoming Nancy Grace Roman Space Telescope will help us find out how common planets are around such speedy stars and may offer clues as to how these systems are accelerated. The mission will conduct a survey of the galactic bulge, pairing a large view of space with crisp resolution. In this case, we used MOA for its broad field view and then followed up with Keck and Gaia for their sharper resolution. But thanks to Roman's powerful view and planned survey strategy, we won't need to rely on additional telescopes, Terry said. Roman will do it all. Isn't it exciting to see that our view of the skies is becoming clearer and clearer with each new development in space telescope technology?
And there it is for another episode of Astronomy Daily, the podcast. I sure hope you enjoyed today's presentation.
Yeah, I really enjoyed that today, Hallie, even though you took one of my stories. But hey, thanks everybody for stopping by. I hope you really enjoyed the show. And don't forget, Hallie's cousin Anna takes the show during the week,
so you don't miss all the news about astronomy, space, and space science as it happens.
And if you didn't get it before, the details of receiving the Astronomy Daily newsletter in your email every day are mentioned earlier in this podcast and every podcast.
You did a great job on that announcement.
Well, you're very kind, Hallie. And we will catch you all next week on your favourite podcast channel.
See you, everyone.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.